going to do a recap of today's lesson, especially for those kids that are sick at home. This was the warm-up we started with, and I made a recording in class, but it was a little long, so I'm going to trim it down here. We talked about estimating. That's the new thing in this book, is we're sticking with a lot of fractions and rational numbers, but now we're going to talk about estimating. And estimating is like an educated guess. And it means that you're supposed to imagine that you are not going to work a problem out and you're going to just do the problem in your head. You're not going to get it exact, you're going to just get a quick, approximate answer. This is a really useful skill, and I'll show you an application in a minute. So when we look at this problem over here, suppose you want to estimate the sum of 1 5/6 plus 1 7/8. What is a good estimate for the sum? So I'm going to show you what two different people in class did. The first person in class said that they think the good estimate is 4. And that's because they really thought of this as 1 plus 1, which gave them a 2. And then they thought that this 5/6 is close to 1. And 7/8 is also close to 1, so that gave them another 2. And so that's why their estimate was 4. So I would agree that that was a good estimate. Okay? But if you look at number 2, it says, is the estimated sum greater than or less than the actual sum? Now, some people went and figured out the actual sum, but you don't really need to. And in fact, the goal is to just be able to make an estimate and say if it's greater than or less than the actual sum. So since I changed this 5/6 in my mind, or the student that was thinking about this, they thought of that 5/6 as a 1. They made the number bigger than it really is. And then they did the same thing for the 7/8. So they made a bigger answer than the actual answer. So we would say 4 is greater than the actual sum. And so we call it an overestimate. That's the new vocabulary word. Another person did something a little bit different. Oops, let's lock that down. A different person, instead of doing this, the second person in the class thought a better estimate, or a different estimate, was 1 plus 1, and then they said these together are, neither one of them's quite one whole, so they did 1 1/2, and they said their estimate was about 3 1/2. That's a reasonable estimate too. So if you had 3 1/2, that's okay. So when you do an estimate, you want to go to whole numbers or halves. But you really don't want to go to anything in between for most of what we're doing. So the way they explained it was, they said, well, I'm going to take a little bit of the 5, a little bit away from here, and make 7/8 a whole, and that gives me 3. And then that 5/6 drops down a little bit, so I'm close to 3 1/2. And so we could say 3 1/2 is also a good estimate, but it is less than the actual sum. because, so we call it an underestimate. So that's a harder one to visualize. So maybe if you put a little picture to that. If this is a half right here, 5/6 is more than a half. So 5/6 would be about this much. And then 7/8 is even more than that. 7/8 is about that much. So together, if we take those two lines and put them together and look at how much they make, I'm going to shrink that up. These together, you think about this being 0, 1, 2, would be right about here. And 1.5 would be right about there. So 5/6 and 7/8 is a little bit bigger than 1.5. So the student that said this is actually correct, but the time that it took to get that answer might be more time than we need to spend when we're estimating. So I think the better solution is this for most kids, because it's a good enough estimate, and that's what we're going for, good enough estimate. They're both good estimates. This one is the most practical because it is nice and easy to work with. On the next page, the next thing we did was we looked at this dollhouse problem. So I'm going to give you a little bit of a briefing on the problem. I'm going to go to 2 views here. And there was lots of directions, but you have to answer the question below, and I rewrote it here. And then you're going to tell whether it's an overestimate or an underestimate. So I'm going to help you with this. This is on page 11 in your book. Mrs. Edwards is building a dollhouse for her children. She needs to buy wood for the railing on the balcony. The wood is available in 12-inch, 14-inch, and 16-inch lengths. She does not want to waste wood. What length should she buy? And so I'm going to call this problem A1. And that's right here, problem A1. And then I added in a problem A2, just for bonus thinking. So the balcony, that's the top railing. That's the railing right here, just this part. Not what you see on the bottom, which is the porch. So for the balcony, there's 3 parts. You have 2 sides that are 4 1/4 in the dollhouse. It's in inches, and one side that's 5 1/8. And I know that from the blueprint. So if we're going to do an estimate, and we know we can only buy lengths that are 12 inches, 14 inches, or 16 inches, we want to overestimate so we have enough. So we can add the whole parts. 4 plus 4 plus 5 makes 13. And then we have a little bit more here, so we're going to add another foot. So we're going to say we need 14 inches, and it's an over estimate. And we want to overestimate so we have enough wood. But then he came up in one of the classes about the bottom. This is the porch, and you need 2 rails of the porch. The book didn't ask about that. But What if the book asked about that? That's a different problem. We'd still need these 3 parts. We'd need all that stuff still. But we would need, in addition, 2 rails that are 4 and a 4 by 4 and a 4. So we would need to still buy the 14 inches here. But we need about 9 more inches. And so we're going to need another piece, but we're going to have to buy that 12-inch piece. So some people were wondering about buying a 16-inch piece. If we used a 16-inch piece here instead, we'd have less than 4 inches left, and we couldn't use it there. So we don't want to buy that 16-inch piece because the scraps wouldn't help us over on this side. And that was what made that an interesting problem. So even though there's more fencing, we're still going to stay with the 14-inch piece and the 12-inch piece. So she would need 2 pieces. One 14-inch and one 12-inch, and she would have some left over. So it's an over estimate.